Continuing with the structural classifications of joints, we'll now examine the cartilaginous joints. So as their name indicates, this is a type of joint in which the adjacent bones are united by either hyaline cartilage or fibrocartilage. So notice that the cartilaginous joints lack a joint cavity in much the same way that the fibrous joints also lack a joint cavity. We see two types of cartilaginous joints, and we have two terms that imply the type of cartilage that's found within that particular joint. So synchondroses are the terms that we use for cartilaginous joints in which the bones are united primarily by hyaline cartilage, whereas symphyses are cartilaginous joints in which the bones are united primarily by fibrocartilage. So now we'll take a look at some examples of where these are located within the body. So we'll start with synchondroses, a couple of examples here of synchondroses, where hyaline cartilage is going to be the predominant cartilage type within the joints that we see here. Now, hyaline cartilage is a tough and rigid cartilage, which makes it ideal for non-movable joints or synarthroses. So these two synchondroses both represent immovable but very stable joints. Hyaline cartilage is very similar to bone in that it can resist compressive forces but not tensile or pulling forces. So you'll notice that hyaline cartilage tends to be found in places where compressive forces tend to dominate. One example here on the left is the epiphyseal plate, and the epiphyseal plate is a plate of hyaline cartilage that exists between the epiphysis and the diaphysis of long bones, and it represents a temporary synchondrosis. So the epiphyseal plate is the region in which the long bone grows, and so we see that this structure is present in teenagers, in young adults, and basically people up until their early 20s. And by our early 20s, the epiphyseal plate tends to be completely replaced by bone, and this is the point at which the long bone stops growing in length, and no more cartilage exists between the epiphysis and the diaphysis of those long bones. More permanent synchondrosis joints exist in the thoracic cage. So this is the example that we have on the right side here in the joints that are called the sternocostal joints. And so these are the joints that exist between the sternum and the rib. So this is the top part of the sternum, this is the manubrium here, and this is the joint that the first rib is making with the manubrium of the sternum here. And you'll see that there's quite a bit of hyaline cartilage between the sternum and the rib itself. So there exists a pretty substantial piece of hyaline cartilage at this particular joint here. And so it connects the ribs to the sternum. And you see the same with most of the ribs, with the exception of the floating ribs, rib pairs 11 and 12 in the skeleton. So these all connect either directly or indirectly to the sternum by hyaline cartilage, with the exception of ribs 11 and 12, which have no connection to the sternum whatsoever. So those are a few examples of synchondroses. We'll take a look at symphyses next. So recall that the cartilaginous joints where the bones are united by fibrocartilage, or that is the bulk of the material that's found in the joint between the two bones, is going to be fibrocartilage, and that's what a symphysis is a fibrocartilaginous joint. So fibrocartilage contains many bundles of collagen fibers. So this is a tissue that can resist both tension or pulling forces as well as compressive forces. So perhaps unsurprisingly, it's found in places where both tension and compression forces are going to be present in the skeleton. So it does allow for some movement between the bones because it is a lot less rigid than hyaline cartilage is. So the collagen fibers within it give it a lot more flexibility. So therefore, symphyses tend to be functionally classified as amphiarthroses. So that is, they permit a little bit of movement, but in general, they have quite a bit of stability as well. So On the left side here, we see the intervertebral discs. These are the fibrocartilage pads that exist between most of the vertebrae in our vertebral column. The bulk of the intervertebral discs between the vertebrae is composed of fibrocartilage, which gives the vertebral column itself pretty decent flexibility. The very thick intervertebral discs also provide a protective cushion for the vertebrae, in particular for high impact activities like jumping or running, and also when carrying heavy objects as well. So this provides some impact resistance to our vertebral column as well. Now notice here too that these little blue, kind of light blue lines here on either side of the fibrocartilage disc are actually little pads of hyaline cartilage, and these little pads of hyaline cartilage on the ends of the two vertebrae serve to protect the ends of the bones there. But notice that this hyaline cartilage is only serving a protective role, and the hyaline cartilage is not bridging the gap between the two bones. So it's not uniting the two bones together in the same way that the fibrocartilage disc is. So that's why this is a fibrocartilage joint, because it's the fibrocartilage that's actually making the connection between the two bones, rather than just protecting the two ends of the bones in that joint there. Another symphysis is located between the two pubic bones, and we see this example on the right side of this diagram here. This is a structure called the pubic symphysis that exists between the two pubic bones at the anterior aspect of the pelvic girdle. Here, the fibrocartilage joint allows for very limited movement at the front of the hip bones, and the function of this joint is to primarily provide stability for these bones, and it helps keep the front of the two hip bones aligned. So stability is going to be really important for the hips, as the hips serve as the structures that are transmitting the weight of the body from the abdomen to the lower limbs, and so the hips are transmitting the weight of the body to the lower limbs, and so stability is going to be really important for those bones and those joints there.